Good morning, friends. We are learning our subject, that is data mining. And in that, we now want to learn classification and prediction. That is our module 4. So, what do we want to study? Here, they are classification, prediction, issues regarding classification and prediction, statistical based algorithms, distance based algorithms, decision tree based algorithms, neural network based algorithms, rule based algorithms, combining techniques, accuracy, error measures, neural network, then prediction methods. They are linear, non-linear regression, logistic regression, and wake up too. Right? This is what we want to study in this particular module. So first of all, let us learn supervised versus unsupervised learning. You can say in the contents it was not there. But see, before learning classification, we should have the idea what is supervised learning and what is unsupervised learning. So let us see that supervised, that is, we can say the example is classification, and unsupervised learning, the example is clustering. Okay, so what is that? Supervision, that means the training data, observations, measures, etc. are accompanied by labels indicating the class of observations. New data is classified based on training set. See, simple example what I can say is, in say our childhood, we used to write 1, 2, 3, 4, 5, right? Digits, fine. Say 1 to 10 numbers you are learning. At that time, what happens that your parents or your teachers teach you that write 1 this way, that write 1 in this way, or you can say you can have 1 in this manner, right? We used to draw that, isn't it? We used to say we have to draw. So how we used to draw? That is, we can say, if we are having the arrow, we can say we'll be writing like this. Then after we'll be having something like, we can have something like this. And then we can say we will be having something like this, right? Something like this we used to say, isn't it? So this is our one. It was being taught to you, but do you think at once only you will remember everything? Probably not, right? Then what we used to do is, when our parents or teachers are showing the picture of this one, we may consider 2 also as 1, right? Or we make the mistake that actual 1 is 2 and actual 2 is say 1. We make the mistake, isn't it? We make the mistake. It happens, isn't it? It happens. So what to do? So what to do? Our parents or teachers first teach us, that is, we can say we are being trained. First thing is we are being trained, right? This is 1, this is 2. So what we are doing is we are trying to capture the pattern in our mind, that 1 means this line, this line, this line, this way. The what you say is 1 is written. Fine. Then after Then after what? 2 is written this way, right? But still we are making mistake. So what happens that our teachers or our parents test it and they have seen that we are making mistake, so they rectify us. No, you are making mistake, don't do so. This way the 1 is written and this way the 2 is written, right? They rectify us, right? Again they are asking us what is 1 and what is 2. They'll show us the picture. If we successfully recognize 1 and 2, then we say that, or they say that, we are getting or we have learned 1 and 2 properly. Isn't it? So, what is this? Our teacher, parents taught us, trained us, test us. Mm, is it this? No? Then rectify us. That is a supervision. Under that supervision, we'll learn, right? And what happens that suppose we are having few videos, say NPTEL videos. We see them, we see, okay, the concept is like this, and we have to apply it this way. Okay, you have learned it, right? What you have learned, nobody is rectifying. Yeah, tests are there. You will be marking the MCQs and you can say that the system will give you whether it is right or wrong. Right? The system gives you it is right or wrong only when the results are there. Right? So what we do is we rectify those things in our mind. Who rectifies? We ourselves. Right? Is there any teacher? Is there any trainer who rectifies us, who supervises us? No. So that is called the unsupervised learning. Fine. You can say that when you are giving the offline exam here at our college, that is called the supervised exam because supervisor is moving in the class and they are looking at you, right? If you are trying to copy something, they'll say, don't copy, sit properly, right? Something like this. So that is supervised. What about unsupervised? That is online exam where you are writing from home and you can say that you are having whole world open to you. From that you can take the things, you can copy, you can do whatever you want, right? So that is unsupervised. Hope the concept is clear. So in supervised learning, we do have the labels indicating the class of observations. For classification, we specifically say that classes are there. What do we mean by classes are there? Third year, final year, fourth year, second year, this way? See, the classes, suppose we are having the group of fruits available. So these are sweet fruits. These are sour fruits, right? This is the class given to it. These are the class given to it, right? You can say that these people will buy the computer, these people will not buy the computer, right? Today, these people will play the chess, this people will not play the chess, something like this, right? So class labels are given based on the observations, the classes are given, or you can say the decision is given through the classes and that labels are given. You already have the data, you already have the observations wherein you have already categorized, okay, this type of fruit is there, its taste is this way, it is sweet fruit. If it is this way, then it is sour fruit, right? So this way the classification, or you can say label, is already given for classification. You can say then what to know, what to know. See, the thing is, it is supervised learning. So the teacher or whatever is the system that trains the data, that trains the observations, wherein it is already given that for this features, this is the sweet fruit. If these features are there, it is sour fruit, right? It is already given. So what we do is we are training the mind. See, for human we say that we are training the mind. Here what we say is we are training the machine, right? We are training the machine. And what happens after that? Test it. Is it giving us proper output? No? Okay, then rectify the output. What do we mean by it is not giving the proper output? We check for the known observations where we already know that these characteristics are there, then it is sweet fruit. So if for any particular sweet fruit, if it is giving say other output, that is other than sweet fruit, then you can say some mistake is there, so we need to rectify that, right? So this is the way the machines are being trained under the supervision, and or you can say supervised algorithms. And what we do after that, whenever new data comes where the label is not there, what we have to do is for that new data, it should be classified based on the training set. Fine. The way we used to do is we train you while in your class, when we ask some questions and you answer, we rectify you if you are wrong in that case. And then after, you can say in your exam, unknown data is given to you, and for that you have to give me the proper output. So this is supervised learning, and especially we are considering classification, right? Classification, in that we are having the labels. Okay, fine. So now next thing is unsupervised learning, and the example is clustering. The class labels of training data is known. We do not have class. So how to train it? Let's see. Given a set of measurements, observations, etc., with the aim of publishing, sorry, the aim of establishing the existence of classes or clusters in the data. Given a set of measurements with the aim of establishing the existence of classes or clusters in the data. What we have to do is we want to group the data based on the characteristics. How can you say on the first day when you are coming to college, on looking at a particular person, you feel that this person can be my friend, right? You may not have talked to that person, only on seeing that person you feel that this person will be my friend, right? It is nothing like that throughout your life that person will be your friend, but you think and you talk to that person. After started talking, you feel that this person is having very similar characteristics to me, very similar characteristics to me, so I'll keep continuing for my friendship, right? So this is the human behavior, and this is what is unsupervised learning clustering, wherein we are trying to find the similarity and we are making the group. You can say that you have made one friend, then other, then third, then fourth, then you can say that all of them are there in the group, right? So this is what is the concept of clustering, right? Now, prediction problems, what are they? In that, we want to say that classification versus numeric prediction, right? First of all, we are learning how the things are there, right? Classification, which predicts categorical class levels. They can be discrete or nominal. Now I should not say, you already know what is discrete and what is nominal, right? It classifies the data, that is, constructs a model based on the training set and the values, the class labels in a classifying attribute and using it in classifying new data. What is numeric prediction? It predicts unknown or missing values. Where the missing values are there or unknown values are there, we are using the prediction. What for classification is that we predict the value for unknown new data. What do we say is, whenever new data comes after classification, we are having new data. For that, we are giving the classification. But for numeric prediction, for prediction, what we used to do is, typically it is being used for missing values. What do we mean by missing values? For example, we are having the data set wherein we are having the student's enrollment number, name, and email address. You can say that in data set of students, we are having, say, enrollment number, then we can say name, and we can say email address, and we can say mobile number, right? You can say थोड़ा Facebook ID भी ले लो, Facebook ID, so that in the alumni group they can be added, right? Okay, so this is what we have decided for getting the students' data. Why do we need to have students' data? Because we can communicate to them in future also. Just now also it is required when you are studying, as well as in future also when you are going for good job or you are having very good company which you yourself establish, or you join, say, family business, right? So such information is required to the college, right? So after pass out of this college, the relation with our college is not broken, it continues, right? It continues. We are in touch. Fine, we are in touch. So for that, what do we get it? We are having, say, this information. We have decided to have this particular information. Fine. Now, what happens? Let me talk the case where we are having the year, say, 2000. Or let's say 2001, because where the first batch of the college was pass out. First batch of our college was pass out in 2001, right? Now at that time, if I could have taken the data of students, could I take this one? All these things, whatever I am deciding today, no, may not be. That time, people were having roll number. University was giving the exam number, right? There is nothing like enrollment number. Okay. Then after we can say that email address that could be there, but mobile that was not available. or if available, then it is available to very rich people, right? Probably it was not there, but still if it is there, then to very rich people. And for students, at least we can say hardly throughout the college one person may have, right? So could we consider mobile number in that? No. Facebook? No, it was not having the existence there, right? Or you can say it was not open that time, or you can say the way we are using today, it was not available that time, right? So what happens that when I have taken the data at that time, I may not have considered this fields, right? Or at least this two, I may not have considered that time because that was not available to all the people, right? So I have taken the students' data only with, say, roll number, name, and email address, right? Now, now what? So if we are having the data now, we can say after 20 years, we will take the data, that is email address and mobile number. We will be taking the Facebook ID, we'll be taking say Twitter ID, we'll be taking say Instagram ID, right? Instagram URL. So today many more things are available. Yes, YouTube channel also. We are having many more things which were not available few years back. So what to do? Why should we do something? Why should we do something? It is because for our subject, whenever we want to take the decision, at that time, we need to have the data of say 15 to 20 years. We need to have the historical data to take the decisions, right? So, say 20 years data, so few years back, Facebook ID was not there. Now it is there. So what? So, when we are merging these two tables, we will be having the students' data wherein mobile number and Facebook ID will be missing, right? For say 2000 one students the FBID, and we can say that mobile number that must be missing, right? That is missing, right? It may happen that if I have collected your parents' email address, then there also we can say that it may not be available. But today, today we can say that each and every person is having email ID. You can say, no, ma'am, it's not like that. See, we can say that person who is having the mobile, almost all of them will be having the email address because without that, the normal smartphones are not working, isn't it? So we can say that these days tables will be having all this information which was not available at that time, right? So when we merge, when we integrate such data, we can say that we will be having the missing values for parents' email ID, you can say Facebook ID, say mobile number, right? So you can understand that. Fine. So what do we say is numeric prediction, that is predicts known or missing values, right? So for missing values, how can it be? That's what I have explained. Fine. Okay. Now, what are the typical applications? That is, we can say credit or loan approval, medical diagnosis, that is if a tumor is cancerous or in the beginner stage, fraud detection, if a transaction is of type fraud or not, web page categorization, which category the web is, right? So We can use the numeric prediction for all this typical applications. Now, till now, whatever we have learned, that was the understanding of these concepts, right? Now we want to know the definitions of these terms. Which terms? Classification and prediction. Now with that, we want to know one more term, that is estimation. So we can say, what is classification? Classification is the grouping of existing data with class labels, right? With class labels. Prediction is the use of existing data values to guess future value. What do we mean by that? Till now, this particular student is having, till now, this particular student, sex student, right, is having 70 percentage as his CGPA, right? So, based on his past history, what I say is this person should be able to get 80% in this semester, right? If I am able to say from the past history of a particular person, if I am predicting, yeah, this person should be having 80 percentage, right? So that is what is the prediction, right? How do we predict? How do we predict? For example, we are having the data year and marks. We plot it, right? If it is say linearly growing for a particular year, this much, for this much, for here, this one, right? So we can say that for a particular person, if his growth is like year is increasing, then that person's percentages are increasing, then then what do we do is, then we predict that whatever will be the next value. This we used to do in our school days, right? We were having the equation, that is y is equal to mx plus b, right? We used to have y is equal to mx plus b, and say few observations are already given for x and y. We put it in the equation and find what is m and what is b, isn't it? We used to find the m and b, and after that, what is there? For say any unknown value of x, we find the y, right? So that is what is the prediction, isn't it? That is what is the prediction. So are we going to learn the same thing which we were learning in our school days? No, this is basic things from which we can learn the other concepts, right? So what do we say is, prediction is the use of existing data values to guess a future value. You may think like, Madam, prediction by astrologer? No. Astrologer is doing the prediction that is based on the, what we can say, our whatever conditions of our grow are there, right? So that's what we consider. Whatever lines of our hands are there, based on that they do the prediction. It is a science, but that is a different thing, right? What we are saying here is, prediction is the use of existing data values to guess a future value. Last time it was this thing, during the January, the sports day was there. Okay, during March, in Tech Fest was there. So this time also it should be having these dates, right? That is what we are predicting, right? So based on the existing data, when we guess the future, it is the prediction, right? Okay. Now, estimation is a prediction of continuous value, right? There are the values, they are the discrete and continuous value, that is known to you, right? So when we say that estimation, estimation is a prediction of continuous value, right? So that is the difference. Okay, so we have learned three definitions. One is classification, second is prediction, and third one is estimation. Classification, what is specific about it is using the class labels we group the existing data, right? Prediction is the use of existing data values to guess a future. And what is estimation? That is a prediction of continuous value, right? Now, classification, it is a two-step process. So what it is? Let us see that. Model construction, describing a set of predetermined classes. Each tuple or sample is assumed to belong to a predefined class as determined by the class label attribute. The set of tuples used for model construction is training set. This fruit, its color is this, its taste is like this, it is this, that, it comes under the category that is sweet fruit, right? So what do we say is we are giving the features of fruits. Based on that, we have already given the training set that these are the fruits which comes under the category is the what is this sweet fruit, right? So what do we say is this set of tuples used for model construction is training set. We want to develop a model where that model will say that whether the fruit is sweet or sour, right? For example, this is the problem. Then what we have to do is we have to construct a model based on the training set. This training set is there. Okay, this type of characteristics have the sweet fruit. This type of characteristics have the sour fruit, right? Something like those things are already given in the training set. From that, the model learns, right? The model is being trained. So the model is represented as classification rules, decision trees, or mathematical formulae, right? Model usage. The two-step process is the classification. The first step is model construction and second one is model usage. Fine. So what is there in the model usage? For classifying future or unknown objects. Fine. So what do we say is estimate accuracy of the model. How to do that? The known label of the test sample is compared with the classified result from the model. Accuracy is the rate, accuracy rate is the percentage of test samples that are correctly classified by the model. Test set is independent of the training set, right? So whatever data is there with us, we are having say 70% percentage of the data for training and 30 percentage of the data for testing, right? So whatever data we are using for test, that is called the test set. Okay, if the accuracy is acceptable, use the model to classify the new data, right? Based on the available data set, what we do is we train it and then after we test it. If the accuracy of this model that is acceptable, then we can say that we can use this model to classify the data. If the test set is used to select models, it is called the validation set. If the test set is used to select particular model, then it is called the validation set. So let's see one example here. That is training data. Now in training data, we are having name, rank, years and tenure, right? In classification algorithms, classifier is that is a model. Fine. Now what we are having, the rule which says that if rank is equal to professor or years is greater than 6, then tenured is equal to yes. So here, what is the decision attribute, that is tenured, whether a person is tenured or not, right? So for that, the classifier model is having the rule, that is, if rank is equal to professor, whatever is given here, according to that we can say that Bill is professor, and so we can see that his tenure is equal to, yes, you can say, but yours is less than 6. But or condition is there, right? Or condition is that if the rank is professor or otherwise, we can say that yours is greater than 6, then tenure is equal to yes, right? So this is our model. Now if we can say that, for say this assistant professor Mike, for that we can say person is assistant professor, so this condition becomes false. But for or years is greater than 6, for this particular person the number of years, that is 3 only, which is not greater than 6. So tenured is equal to yes is not selected, so we can say tenured is equal to no. Fine. If we say that for the way assistant professor is there, yes, and then after the number of years, that is equal to 6. Is it greater than 6? No, it is not. 6 cannot be greater than 6. So for this person also we can say it will be having no. Tenured is equal to no. So let us consider for associate prof. For associate prof, that is NA, the experience is 3. What is there in our condition? That is, if rank is equal to professor or years is greater than 6, we can say tenured will be yes. But for this associate professor, we do not have any conditions satisfied, isn't it? So we can say that the person will not be tenured, right? That is NA. For NA, we can say that tenured is equal to no. Fine. Now let's say that for say Jeff and professor is the new unseen data. This is the data set, that is the training data. Now what are the conditions? What are the rules in that? That is if rank is equal to professor or otherwise years is equal to 6, then we say that tenured is equal to yes, right? Okay, so what about this unseen data? That is, we are giving the new data to this particular model and we should get the output that should be satisfying the real data, right? So Jeff and professor, what was the condition for us? If rank is equal to professor, do we have that? Yes, this person is having the rank as professor. So what is the condition? This or this one, then we can say that tenured is equal to yes, right? So if the person is professor, no need to check for years. That person is tenured, right? So that's what is here for Jeff and professor. The experience is of 4 years, but but it will be, that is, this person will be having tenured. Yes, yes, yes. Okay. Now we want to know about the distance-based algorithm. Classification algorithms we want to study, and for that we want to have the distance-based algorithm. So what are the distances we need to find? There are few methods for finding the distance between 2 points. One we used to do in our mathematics, that is find the distance between x and y. 2 points are given. So here we want to do the same thing, but many more methods are also available. So this typically we used to do, that is Euclidean distance. So we used to find it as it is equal to under root of sigma xi square, sorry, sigma xi minus yi whole square, right? This is what we used to have in our mathematics, right? Second one is, we can say that Manhattan distance. See, there are many scientists who have given the methods to find the distance between 2 points, right? So according to Euclidean distance, it is under root of sigma x minus y whole square. That is xi minus yi whole square. What is Manhattan distance? Manhattan distance, for that we can say sigma is equal to 1 to n mode or absolute value of xi minus yi, right? Then after we can say Minkowski distance, and the formula for that is under root, which under root? It is square root. No, it is p root, right? P root of sigma is equal to 1 to n, and here we can say xi minus yi mode value whole raised to p, right? So that is Minkowski distance. Then we can say cosine similarity, that is being found as a dot b upon a, that is the mode of a dot mode of b, right? One more distance formula, that is Chebyshev. What it is, that is equal to maximum of xi minus yi, that is the maximum value distance, right? So these are the distance finding methods, and we can say in next class we'll study the distance based classification algorithms. Okay, so that's all for today.